Well, good evening, everyone. I'm Matthew Scott. I'm the president of Carnegie Science, and it's my pleasure to welcome you to our headquarters. Our science spans cosmology, astronomy, physics, geophysics, geochemistry, a full range of biology and ecology, a wide spectrum of work. I am a biologist, and as someone relatively new to Carnegie, I'm learning from my colleagues about all these fields I didn't know about before. In particular, I enjoy learning from our Carnegie astronomers who are located here in Washington and in Pasadena, and at our telescopes in the Atacama Desert in Chile. One of the more amazing things I have learned about, especially from our astronomer, Drew Newman, is gravitational lensing, an idea described by Einstein in a 1936 paper and observed first in 1979. Imagine a galaxy that lies between us and a more distant, faint galaxy. Einstein proposed that the light from the distant galaxy would be bent by the gravitational field of the nearer galaxy, which therefore acts as a kind of immense lens. The distant, faint galaxy is magnified by the lens as a result of the bending and focusing of the beams. I think this is a beautiful metaphor for Einstein himself. His ideas were so powerful, like the gravitational forces of a galaxy containing billions of stars, that he distorts and twists our perception. Just as a galaxy can bend light and unveil hidden wonders, Einstein's ideas bend our minds and unveil hidden wonders. Albert Einstein has a long and important history with Carnegie Science, as you can see from the photographs displayed here and out in the rotunda, many of them taken at our Mount Wilson Observatory east of Pasadena. So it is fitting that tonight we are collaborating with Walter Isaacson and the Aspen Institute and with NOVA in this beautiful space that perpetuates the legacy of Andrew Carnegie and his mission to advance fundamental science. I am happy to tell you that Walter has joined the Carnegie Science Board of Trustees, and we're delighted with that. Thanks to all of you for being here with us tonight, and I would now like to introduce Chris Schmidt, the producer of the film you'll see tonight, Inside Einstein's Mind. Chris, over to you. Thank you.
Thank you. After the film, you're going to be hearing from Paula Apsel, the senior executive producer of NOVA, who will run the panel. But for the moment, I'm the representative of NOVA and the big team of people who have made this film that we're going to show you tonight. And it was drilled into my head so strongly that we had a very short time to talk before the film that I actually wrote my comments down, so I'm going to read them to you. Tonight, NOVA is proud to present this sneak preview of Inside Einstein's Mind, a film that marks the 100th anniversary of the publication of one of the most foundational insights in the history of science, the general theory of relativity. The idea that space and time are shaped by matter to create what we experience as gravity is some pretty tough sledding for a filmmaker or a storyteller. Making a film that tells that story is a big challenge. But that's NOVA's bread and butter. As you can imagine, we had to make some tough choices about what we were going to pack in and what we would have to leave behind. And as a consequence, the film doesn't talk much about an aspect of relativity that is particularly near and dear to me, and that's the malleability of time. The notion that the flow of time is relative and that it depends on one's frame of reference is electrifying. Excuse me. As a kid, the idea that you could set off in a spaceship at close to the speed of light and reach a distant star without growing much older blew my mind. And it just filled me with a crazy longing to get off of this rock of a planet and get out there and find what secrets the cosmos had to offer. Now, fast forward a little bit, I'm no longer a kid, and I find quite by accident that I'm part of a team at NOVA whose job is to warp and manipulate the flow of time across many, many frames of reference, not by traveling at relativistic velocities, but simply by telling a story. At NOVA, our frame of reference is the 51 minutes, 51 seconds that PBS gives us each Wednesday night. That's 3,111 seconds. At 30 frames a second, well, actually it's 29.97 frames a second, so bend your head around that. At 30 frames per second, that's 93,236 pictures. It's a fixed number. We can't change it. Yet somehow, when we succeed in that fixed interval, time shrinks. If we do our job right, within your frame of reference, time will speed up. The story we're telling will pick you up and carry you forward at such an exciting pace that you'll feel enlarged and inspired by the ideas that are taking root in your head. Tonight, NOVA is proud to present this, I'm not used to reading this stuff, I usually do it extemporaneously. That's our version of special relativity. To help us, our director, Jamie Lockhead, did a beautiful job of visualizing Einstein's simple yet powerful thought experiments. And as you'll see, we rely heavily on a distinguished group of scientists and historians to help us tell the story. One thing we don't do in our story is speculate about anything so squishy as how rapidly or slowly time flowed for Einstein while he was deep in his work. I suspect that when he was most profoundly immersed in his story, time seemed to vanish altogether. We hope that when you are immersed in his story, you will be able to share just a little bit of that exhilaration. Before we get started, I just want to say thank you to the Carnegie Institute, to WGBH and NOVA, and to John Berdar, who's here tonight, who's our VP of National Programming, and especially to our funders, Google, Cancer Treatment Centers of America, the David H. Koch Fund for Science, the Corporation for Public Broadcasting, Roger and Vicki Sant. So everybody, please enjoy the show.
Chris, Paula, thank you for such an exceptional documentary. Thank you very much. Several days ago, I came to appreciate just how beautiful and elegant this great theory of science is through an email exchange that I had with a group of scientists. The big idea. I had the idea that we should put an equation on the cupcakes that we serve tonight. The caterer and my colleague Caroline informed me that the equation for the general theory was just a little too large. So I wrote back on this great chain of 6 or 7 scientists that maybe we could abbreviate the theory of general relativity. I will be publishing as a dissertation the 20 responses I got back in the first 5 minutes. My name is Eric Motley. On behalf of the Aspen Institute, I want to thank you for coming. I want to thank NOVA. I want to thank the Carnegie Institution of Science for collaborating with us. I want to thank a number of guests that we have here tonight. We have representatives from the White House, the Department of State, HHS. We have Supreme Court Justice Stephen Breyer with us. We have our sponsors and underwriters, Michelle Smith of the Robert H. Smith Family Foundation, as well as Jackie Mars of the Mars Family Foundation and Mars Incorporated. I'd like to invite our panelists to come to the stage now. I'd like to introduce you to Margaret Merchan, who is an astronomer and the Deputy Science Director here at the Carnegie Institution of Science. I'd like to introduce you to Professor James Gates, who is one of the leading theoretical physicists in the country, who had a wonderful cameo appearance in this movie. I'd like to introduce you to one of the leading public intellectuals and biographers in the country.
Boss, he has to say.
Let me tell you how great Walter Isaacson is. Walter Isaacson who is a biographer of Steve Jobs, Benjamin Franklin, but more importantly tonight, Albert Einstein. And then Paula Apsel, who is the senior executive and producer of NOVA and who's given us over 100 great documentaries of science. Thank you very much.
Thank you. Can you hear me? Is this on? Okay, great. So thank you very much, Eric, for that warm introduction. Thank you to Carnegie. Thank you to Aspen. I'm sitting here with three brilliant people to comment on Einstein. We only have 30 minutes. If there were ever a time for time dilation, it is now. So Walter, let's start with you. So Einstein was hailed as a genius for his profound intellectual achievement, and in many ways, he's the epitome of the lone genius working against the odds and coming up with something truly revolutionary. Now, this is a stereotype, but in this case, would you say it's a true one?
It's true, and it's a bit of an anomaly, because most science is a collaborative team sport, as Carnegie Institution of Science will tell you. You bring people together. But you have the twin pillars of our physics today, which is quantum theory and relativity theory. And in 1905, working pretty much alone in the patent office, he comes up with both. And in fact, we see at the end of this show that they're sort of not reconcilable at the moment. But we have to remember both of them come from 1905 papers. In fact, he wins the Nobel Prize eventually for the one that starts quantum theory and then does the beginning of relativity theory in that year when he's working alone. And of course, he's working alone as a lone genius pacing around at the end of World War I. And, you know, Germany is losing the war and they're starting to blame it on the Jews. He is somewhat isolated, even by the time he does that. And so on his deathbed, he's still trying to reconcile those two theories that he had started in 1905, relativity and quantum theory. And he's trying to get, you know, in Princeton at the hospital, just a few more lines that are going to get us closer to a unified theory that will explain the connection between gravity, the waves of space, and or in other words, why did that compass needle twitch and point north?
So we can only wonder, really, if he had just been allowed 20 more years, what would have happened. We'll talk about that later. But Jim, I'd like to continue on this same theme with you. Science is now very different from the way it was at the beginning of the 20th century when Einstein was working. It's more expensive. It depends on government. As Walter pointed out, it's often done in enormous groups. Yet you're a theoretical physicist, and one would imagine that the lone genius idea resonates with you. Is there still a role in science for that, for the individual working alone and coming up with something really revolutionary?
Well, also I agree with Walter that Einstein was so singular. However, I still think there is such a role, but it's much more complicated now because of this thing we call the internet, which is like this enormous data feed to those of us who are scientists. We are plugged into this thing every day. And so now it's going to take a different kind of genius. Yes, the genius is going to have to go away and contemplate, but the genius is also going to have to be someone who knows how to crunch through massive sets of data that come to him or her via the internet. But I think the purity of the dream, I think, will drive the process. You know, in your introduction, you mentioned I am a theorist. I've been dreaming about doing physics essentially since I was 4 years old. It has driven my entire life. And I think that kind of purity of dedication, I think that will continue to drive individuals set inside of massive networks that will allow our species to advance.
So just on this theme again of Einstein's character and this lone genius idea. So Walter, you quoted Max Born in your book saying, for all his kindness, sociability, and love of humanity, Einstein was nonetheless totally detached from his environment and the people in it. So I think a lot of people believe that this is characteristic of scientists in general. Was it true about Einstein? And is it true, do you think, in some way, is it characteristic still of scientists?
I do not think it's characteristic. I do think that Einstein never developed a school, never developed people around him. But you have around the same time the other great quantum theorists, I think we would agree, Niels Bohr and others who are forming a Copenhagen school, working very much in unison with people. So I think Einstein's a bit of an anomaly in that regard.
So, Jim, what do you think about this? Is this characteristic in some way of scientists? Because I think it is part of the stereotype of scientists. And yet, I have to say, most of the scientists I know are not like that at all, or they don't certainly seem like that. That's not their public face. What you know a lot more people in the scientific community, what do you think?
So I think it's actually is sort of characteristic in the following sense. I think scientists actually have different phases. And so when you're working as a scientist, and I know this is true for me, when I'm really thinking about my science, I even tell my wife to leave me alone. She's sitting here in the audience, so she can attest to that. Because I have to, in some sense, it is a deep meditation that one goes, and that's the only way I know how to describe the process that goes into this. And then the other strange part of it is that for us, those of us who work on theory, it turns out that mathematics is a kind of a language. And so we struggle to write novels in this very bizarre language. And that is such a great struggle that you have to be able to get away. On the other hand, you have to also be able to accept the criticism from one's colleagues, because that will keep you on the straight and narrow. You can fall so deeply in love with one of your own ideas that you cannot see its flaws.
I have to say one thing about you, Jim. Jim has twins who are very brilliant, one in biology, one in physics, and you're always talking about them. And I think that was one thing with Einstein, that his relationship with his sons was not certainly as close as you have with your kids.
Thank you.
So, Margaret, going to you, is Einstein's scientific style of creativity and challenging the status quo encouraged in the training and the funding of young scientists today?
You know, I worry that it's not encouraged enough, because I think, and Walter makes this point in his book, that Einstein's character of, challenging authority and challenging what was understood to be the status quo, and working in the patent office, in fact, really led him to a very critical style of thinking. And I think that, young scientists today are also equally very creative and critical of the status quo, but they're also forced to be practical in order to secure funding and to secure a tenured position. There's a very regimented path that a scientist has to follow. And so I sort of tried to amuse myself earlier imagining what Einstein's proposal to the NSF to pursue general relativity might have looked like, where we're encouraged to point out, well, if I find this data, the answer will be A. And if we find this other data, the answer will be B. And that's typically with the funding constraints being what they are today, that sort of cautious proposal, I think, is the kind that typically proceeds, unfortunately, rather than the really ambitious ones. There aren't a lot of points awarded for originality. So I think that's something that we have to try to foster more with young scientists, to think big.
Yeah.
Sure. As someone who's been functioning in this constrained environment, so I'm 65, and I think that one of the peculiar things about the way science gets funded now is that only now am I allowed to be as creative and take really large chances of failure. And I think that's what's going to actually happen, is that more and more we will push when you are allowed to think outside of the box. So right now, I'm thinking about really weird things where directions are colors, and I think that, there's a computer code that somehow seems to be embedded in the equations like Einstein's. When I was young, I could not have done that. And so I think that's, in fact, the price that the system is going to pay.
So do you see any thinking now in the system of how that can be changed and how less predictable research can be supported?
Are you asking me, or?
Both of you.
The short answer is more money, but that's not exactly an easy answer.
So as you know, Paula, I also have a policy hat. I advise the administration on issues as a member of the PCAST group, the President's Council of Advisors on Science and Technology. And I can tell you that this is a point that we often debate in the context of PCAST is how do we maintain the health of the science enterprise in the United States so that we can bring what seems to be an almost peculiar American trait of innovation and keeping us on the cutting edge. There are strategies that have been discussed in some of our reports to the president, but as Margaret said, the simple answer is one that is not easy to enunciate. And so on the edges, it's around the edges that maybe we can allow for some of this creativity to bubble up of a new generation.
So, Margaret, let's go back to you because the last part of the film is on the resurgence of general relativity linked to the emergence of astronomy and astrophysics. So you work on planetary formation, and I'd like to know what was the impact of Einstein's revolutionary idea on your own development as a scientist, on your own work? How did you first encounter it, and what kind of an impact did it have on you?
Let's see, so the first exposure I had to general relativity was probably in science fiction as a grade school student, as I think is probably true for a lot of people in reading popular science and this discussion of space-time, and that stuck in my mind, and I thought, the space-time thing, it's really hard to wrap your head around. I mean, a couple of decades later, that's still true for me, but, it plants this seed. I think I don't have to tell you at NOVA about the power of a story, but you get to thinking about something, and for me, I just kept thinking about astronomy and thought, well, I'll just do this until it gets boring and there's nothing else to figure out, and that's not yet come. So here we are. And I think also that, again, and Walter mentioned this about Einstein's engagement with the Bernstein book. You get these little vignettes, and they get your mind going. And I mean, for me, it was general relativity, or at the time I just understood it as space-time, or this bizarre curvature of space and matter in the universe. But it's interesting how these seeds get planted.
So in some sense, it was a formative experience for you. Jim?
And my experience is rather similar. In fact, in talking to my friends who are scientists, we all seem to share this almost common story. For me, it was science fiction also. At the age of 4, seeing a movie on an army base in St. John's, Newfoundland about space travel, and understanding almost immediately was science was the way you got to go to those places. That without science, you couldn't go there. And so I was set on a career in science. And let me just pay tribute to Walter, because Walter's book on Einstein, he asked me to review it before it was published. And it's a brilliant piece of work that captures Einstein, I think, more fully than anything I have ever read. And but the thing that was really interesting was that Walter laid out the narrative that most of us sort of stumble on piece by piece and by accident, and it creates an arc of a human life. And after all, I think that's what is the most motivating thing about doing science, is that you create an arc that allows you to go from this intensely personal experience to contributing something that, if you're lucky, matters for our entire species.
I have to say for myself, one of my earliest memories was when my mother and my grandmother were crying in the kitchen. And I was still a little girl. I really didn't see, grown-ups cry very much. And I asked them what was wrong, and they said that Einstein had died. And I remember thinking about it as I walked down the street. He was such a revered figure in my house, partly because he was a scientist, and of course partly because he was Jewish. But, and it really struck me. Walter, going back to you, there always seems to be a real tinge of tragedy around the end of Einstein's life, before this resurgence of interest in general relativity, when physics is all about quantum mechanics, and Einstein is sort of on the outs. He's no longer in the mainstream. And although he's still revered in terms of working physics, he's really kind of off on his own. As you wrote your book, did that strike you as very sad or tragic?
He was very much a rebel, and this was what causes the two great pillars of physics, relativity and quantum theory in 1905. He just questions things like, Newton begins a Principia by saying time marches along second by second, no matter how we observe it. You get this patent clerk who says, how would we know that? How would we test that? So he's very rebellious, and he keeps being rebellious from 1905 to about 1925, 10 years after general relativity, we're still pushing quantum theory. But quantum theory really begins to bug him because it says that things happen at the subatomic level by chance, by probability. And he says, I cannot believe God plays dice with the universe. And so he begins to become a resistor to where quantum theory is going. Heisenberg's uncertainty principle, Schrodinger, all the others. And at one point he realizes that he's become a resistor to the new rebels. And he said, God punished me for my contempt of authority by making me an authority myself. And so I think he knew it, but let's be clear. In the end, he's trying to get that unified field theory. And what are we doing today? What is Edward Witten doing with string theory? What are you doing, with your mathematical physics? Is let's see if we can get that theory that unifies the two things Einstein came up with.
So you quoted him, Walter, as saying about his old age, and this quote really struck me. The intellect gets crippled, but glittering renown is still draped around the calcified shell.
He liked
Wow.
being famous.
And you asked the question, which I'll ask of you and all of you, what made Einstein go into this, as you called it, defensive crouch, when he was confronted with quantum mechanics, a theory that was as revolutionary as general relativity was?
We will call it a defensive crouch until he turns out to be right that God doesn't play dice with the universe. At which point we'll say, even on his deathbed, he was paving the way. Jim?
Well, I don't think I would quite phrase it that way. I think in the end, the thing to understand about Einstein, and again, I'm not doing a commercial, but read his book. In the end, the thing about Einstein that is truly amazing is that he expresses something so deeply human. Another of his quotes, which is one of my favorites, is that I'm paraphrasing, one of the most remarkable things we can experience as humans is the mysterious. And I think that at the end of the day, he made his peace with that experience of the mysterious and trying to bring that more fully into our comprehension about what that mysterious nature of the universe is. To me, that's the essence of Einstein. He also talked about about mystery being the source of both art and science. So he wraps it up with this idea of mystery.
So wait, so you don't find anything kind of poignant or tragic about Einstein kind of being on that different path at the end of his life, and this old man scribbling equations to get to a grand unified theory that he'll never get to, that kind of I do? You don't find that?
Well, one of the strange things about being a scientist is you come to understand that it's not all about you. And so what that basically means for scientists is that at some point, a member of our species will get this right. And the fact that it didn't happen when Einstein was laying on his deathbed is rather immaterial.
So, Walter, what about when you...
I have to wonder if he would find it satisfying if he had finished all the answers and finished unified theory, because then there would be nothing else to do. Then you would yearn for some other question. And so in a way it's fitting, there's still something yet to be done.
The beginning of the 20th century, in 1900, where this video starts, they realized it's irreconcilable what Newton had discovered about mechanics and what Maxwell had discovered about electromagnetism. And that irreconcilability leads you to Einstein. As we go into this century, the irreconcilability of quantum theory and general relativity is what leads us into this next century. I do not find it tragic at all that we still have that mystery to solve.
And let me, if I may just leverage off that, there are numbers of us who are working as theorists. We think this next mystery is pointing towards information, that somehow information is at the root of the description at the most fundamental levels of how this thing we live in works, that is something about information.
So is this another 300-400-year quest, as it was the path from Newton to Einstein to us today? Or is it something that some scientist, as Sean Carroll says at the end, living in Kenya somewhere or another country, will perhaps find? How close are we to reconciling these two theories?
Well, first of all, I wouldn't talk about a 300 or 400 year quest. I'd talk about a 3,000, 4,000 year quest. Because when we do reconcile them, we will enter the next century, and there will still be some mystery, as Einstein said, that we'll still have to reconcile. And, you know, he was the greatest mind reader, the creator of the cosmos, but I don't think anybody's ever going to get it totally nailed. I love the quote in 1900 when the head of the British Academy says, everything there is to be discovered has already been discovered. If we ever get to that point, we're in bad shape.
One thing that really amazed me when I learned about it was that, not even having completed his theory, not even positive that he could, Einstein schedules these 4 lectures at the Prussian Academy in Berlin, placing just an enormous amount of pressure on himself. Was this courageous, overconfident, or just foolhardy?
It was definitely a mistake, and he regretted it. But what's really the problem is not that he has these 4 lectures that he's committed to. You know, we all get committed to deadlines. It's that Hilbert, that guy there, in Göttingen, is trying to come up with, and he didn't have time to put it in, but every day, not only is he getting letters from his wife, Mileva, saying, hey, what are you going to do for the kids for Christmas? You know, and we're talking about, we're in mid-November, but he's getting letters from Hilbert that sort of sweetly say, guess what? I've actually come up with some equations that solve this. And Einstein's not eating. He is furious, actually. I think, you know, we have some letters at Hilbert for trying to, what he called nostrify, basically plagiarize his theory. And so he's racing not just against the deadline of the 4 lectures that end on the 3rd week of November 100 years ago, but he's racing against Hilbert, who is also giving a series of lectures.
So has it ever been looked at how close Hilbert actually was?
Oh, God, yeah, there's a great Hilbert-Einstein priority dispute. But what Hilbert says, which is so important, is, in the end, this is Einstein and only Einstein's theory. He was just trying to get the mathematical equation. And he said these beautiful equations, which Einstein gets the credit for, whoever of us added to it, it was to do Einstein's theory, not, Hilbert doesn't try to claim credit for the theory.
It's interesting that you bring up the notion of competition, though, as a driver, because we were just talking about before the panel that it may be some sort of competitive drive that pushes us, perhaps as a nation or some subset thereof, that gets us to really invest in science as we did maybe 50 years ago. And so I wonder if that might be some of the, you know, the oomph that we need to get to what you're talking about, whether it's going to be 300 or 400 years for the next big step or not.
And that's what I want to come back to, because I don't think it's going to take that long. For this simple reason that we are networked together, mind to mind, in a way that has never existed before. It's true we need the spark of genius to drive the breakthrough, but
Well, we have it right in the room with us, so not a problem.
But the connection to people, mind to mind, that has a power that we are only beginning to see manifest in this society. We call it data analytics when we harness it with hardware and software. But that kind of connectivity, I think, is actually going to get us to the next stage much more rapidly than we would otherwise.
So that leads me into this final question, I think is pretty much all we have time for, that the MIT physicist and historian of physics, David Kaiser, whom we saw in the film, just published a recent piece in the New York Times in the op-ed page, and he wrote this: a century after its creation, Einstein's beautiful theory continues to inspire lofty thoughts about black holes, supernovae, the Big Bang. The history of Einstein's work, however, reveals how even the most abstract scientific research can be buffeted, derailed, and even propelled by the most potent force of all, politics. So, Walter, it would be really interesting to hear a bit about how Einstein and general relativity were affected directly by politics and the events of the day. And Jim, you serve on President Obama's Council of Advisors on Science and Technology, And Margaret, you're an administrator at this great research institution. Is there an analogous situation going on today? Do you believe that the federal investment in science is under threat?
Oh, well, I would say certainly it's been on the decline for quite some time, since at least the 1970s, and that's what, I mean, I'm, giving a plug for our institution, but I think that's what makes an institution like Carnegie Science so important, where we can offer an environment where our scientists are protected from the whims of federal funding, and I'm not sure that this is still working, and can take their directions in whatever, direction curiosity drives them, and then they're free to make the mistakes and take another turn, and then this environment respects those twists and turns that basic fundamental research, I think, must take.
Jim?
So, as someone who has been charged with worrying about these things, I fear more for my country's future now than I have ever in my life, quite frankly. One of the things that is so frightening is the way in which we have an environment where politics often seems to overrule science. There was a time in this country where when a scientist or a group of scientists or a scientific organization made a pronouncement, you did not immediately have a skeptical opposing force come and dominate the popular media. But now with this is the downside of all this connectivity that I was telling you about, is that now when scientists make a pronouncement, you can, and if it's against an interest, that interest is capable of generating what I like to call anti-science. And then we see it happening all the time. And so the public in general gets left in a position of not knowing who to trust. And that, to me, is the most dangerous process I see at work in the country, that our public will lose confidence that our scientific establishment is working to a set of principles for the benefit, first, of the country, and then perhaps of the world, but most definitely as a handmaiden to create the next great chapter in this thing we call the American dream. This worries me profoundly.
Well, and by building on that and going back to the original part of your question about politics and Einstein, and obviously nobody has ever been affected more by the gravitational field of politics than Albert Einstein in 1933 as the Nazis come to power. And what happens? Einstein has to leave, Niels Bohr has to leave, Enrico Fermi has to leave. I think in my book I have about 27 people, all of whom then collaborate after Einstein writes a letter to Franklin Roosevelt and explains, basically, coming out of E equals MC squared, that you could split an atom and it can make a weapon. So they collaborate and do that, and the US is able to create atomic weaponry, and Germany isn't. So that's one of the great examples of politics distorting science. After the war, the guy who runs that program, Vannevar Bush, writes an essay that everybody should read. It's called Science, the New Frontier. And it says that we have to invest in basic research. That as a nation, as Jim just said, if we're going to not only create new innovations, but create dreams and visions, investing not just in very specific scientific things like GPS systems, but in very basic theoretical things. And what he says is by investing in pure basic science, you will lay the groundwork for all future inventions and thought and advances that are beautiful. And that's what we do under President Eisenhower. You say it takes a precipitating moment, Sputnik goes up, whatever. They create a whole federal system to have basic science funded, and we've dismantled that today. And I'll end with something about the Carnegie Institution for Science, which is, if you look at even the advances of the computer, it was a collaboration funded by Carnegie of people doing, observations of the weather patterns around the world, and we brought in that Mauchly was doing, and his son is helping him, and his son goes on to create the first real computer, ENIAC, as a collaboration. The notion of collaboration, the notion of basic research taken away from politics is what the Carnegie Institution is about, and which our federal government is not about anymore. So thank you, Carnegie. Appreciate it.
I think on that note, our discussion is ended. And Eric, Walter, I think you have the last word.
Well, the last word is, it is the 100th birthday. So we're going in the rotunda here. We will have a party. We hope to have big bangs and black holes and lightsabers that bend light. But thank you, Carnegie. Thank you, Nova. Thank you all. Thanks for being here. Far too far.